Good morning, everyone. Thanks for joining. I want us to start this class. And before we start, are you guys able to hear me? Am I audible? Please confirm. Am I audible, guys? Please confirm. Adiru, Adeboye, am I audible? Florence, please, can you guys confirm whether I'm audible? Okay. Thank you, Winnie. Thank you, everyone, for confirming. Okay, so today we are looking at chapter 10 or module 10. And module 10 is about network services. Module 10 is about network services. Okay. Now, there are things that you are familiar with. Some of the network services that we know. Okay. So upon completion of this chapter, you should be able to explain how network services enable network functionality. And which are these network services are we talking about? Now, there are quite a number, as you can see. We have the DCP services, DNS services, NAT services, FTP, email, HTTP, and others. There are quite a number of these services that will enable the network functionality. So it's very, very important to understand these network services. So let's start with DCP, or to start us off is DCP. So how does DCP operate? How does DCP operate? Okay, that is, we said when it comes to the assignment of the addresses, there are two methods that can be employed. It's either you're using a DCP or static when it comes to the assignment of the addresses. Okay, so for the DCP, as we all know, it is the server assigning you the addresses. But for the case of the static, it is you now, the network admin, assigning the PC's addresses manually. You assign those PC's addresses manually. So when a host connects to the network, the DCP server chooses an address from a configured range of addresses called a pool and assigns it to the hosts. So DCP can allocate IP addresses for a configurable period of time called a lease, okay, or a lease period, where actually the PCs will be leased with addresses for a given period of time. So it means when you have been assigned an address, it's not yours permanently. You have just been leased for a given period of time. So when the lease period expires, now it's supposed to contact, right, the server for the same address, or you can request for another one. Okay, so this is practical with the following type of networks. It is practical with the following type of networks: medium to large networks, okay, and also home network. You can actually have all these, okay. But static is just recommended for a smaller network. So what are the operations of DCP? How does DCP operate? How does DCP operate? Okay, so there are four main operations here. Now you, as the PC or the host, you want to request the IP address for the server. First, you need to know whether that server is there online in the first place. Is it online? The server is online. If it is online, then okay, you need now to get some offer from that. So the first operation here is the DCP discover. You can see to identify any available services or DCP services on the network. So if you find that it's online, then you get the offer, meaning you'll be offered what is available within the pool. What do you have within the pool? All the available IP addresses not in use, okay, will be assigned to you. Then you need to accept some of those addresses from one pool or from different pools. So you decide which one are you going to select. So you send a request to the server that, yes, I've accepted the offer with what actually you have accepted. So it's very important. Then finally, there will be an acknowledgement that, yes, your request has been accepted, and that now will be your IP address forever. Not forever, but for a given period of time, for the lease that will be assigned. So if the IP4 address requested by the client or offered by the server is still available, the server returns the acknowledgement message. If the offer is no longer valid, then the selected server responds with a negative message. So this is a negative acknowledgement, meaning that IP address you're requesting for is no longer available. It has been assigned to another device. That's what actually it is responding back with this. So if a DCP NAC message is returned, then the selection process begins. Again, the new DCP discover message being transmitted. So that's actually how actually we need to see the 4 operations for us to get that. Okay. Then, of course, there's a format for this DCP. The format, okay. And all the format that we have is being used for the DCP version 4 transactions. The messages are encapsulated within the UDP transport protocol. The below table lists the fields covered in the structure of the DCP version 4 message. You can see some of the fields that we have: operation code, hardware type, all this. Okay, what actually enable it to operate as a DCP? It means there are some fields that must be available for it to be able to operate. The other service is the DNS service. That is domain name system. The domain name system. Okay. So this domain name system provides domain names and their associated what? IP addresses. And their associated IP addresses. So the DNS system consists of a global hierarchy of distributed servers that contain databases of a name or of name to IP mappings. So the client computer in the figure will send a request to the DNS server to get the IP address for that, so that it can address packets to that particular server. So it's very important, that mapping. So remember, all the DNS that we have in this case must be assigned an IP address. And mostly, if you look at those IP addresses, they are always public. They are always public IP addresses. And you can query that one using NSP, how do you call it? NS lookup. NS lookup, for example. It will query all the what? All the DNS together with the IP addresses assigned to them. If you can remember that one right from stage 1. Okay. So this one is the hierarchy. The domain hierarchy that we have. The domain hierarchy, as you can see, right from the root level domain to top level domain. Okay. Then second level domain, depending with the different domains that are available. So that's the hierarchy. And that's why sometimes when you request something from your server, you might find that your server might not have it. So it will force it to send that request to another available server on the network to check whether that particular request is available. And that's why actually it has been arranged. So you can see on these servers, we have the ones with different domains like .net, .edu, .com, .au, .co. Okay, so if your server does not have anything to do with that, maybe .education, then it will actually send a request to that particular server. So this is the highest level. No? So if it's not found here, then that means whatever you are trying to request is not available. So that's the concept you need to understand, that always this a searching engine kind of, and it is just search whether in your local server or remote servers that are there. So subdomains are found at the next level of the DNS hierarchy and represent some divisions of what? Of the second level domain. Fourth level domain can represent a host in a subdomain. Then top level domains represent either the type of organization or country of origin. Examples, .org for the nonprofit organizations or .au for the Australia. So you can see this is the hierarchy that you need to understand, especially when doing a request or a search within your network, local network. So these are the processes, the lookup process, when actually you're trying to search for something on your server. So these are the processes that we have. So to resolve a name to an IP address, the resolver will first check its local DNS cache to see whether it is there. So this is your local DNS cache. Okay. Then, if the mapping is not found, a query will be issued to the DNS server. Okay. If the mapping is not found there, the DNS server will query other higher level DNS servers that are authoritative for the top level domain in order to find the mapping. So these are known as what? A recursive query. So something that it will keep on searching until your request is processed. But if it's not available, again you get the same response, the same message that whatever you're trying to request is not available on a network. So the caching DNS servers can resolve recursive queries without forwarding the queries to higher level servers. They can deal with that. Okay, they can deal with that. So a DNS, you can see here DNS recursive resolver. They can just check that one. Okay. But if it's not here, then that's the time now, it will now send that query to other available servers at the top level domain. So if a server requires data for a zone, it will request transfer of that data from an authoritative server for that zone. The process of transferring DNS data between servers is known as zone transfer. So we have zones, the local zones, the remote zones, just to check that particular request. Okay. And again, it has the following format for it to be able to work effectively. Then the following fields are very, very important for that matter. Okay. For example, you can see we have the UDP header. Okay. And also with the port number that it has been assigned. Okay. As you can see. So if a DNS response exceeds 512 bytes, then dynamic DNS is used. What is known as DNS will be used. So the DNS protocol communications use a single format called a message. DNS uses the same message format for all types of client queries and server responses, error messages, and transfer of resource record information. So these are very, very important when it comes to the queries of the DNS top level servers or the local servers in this case. So these messages, the DNS uses them for all type of client queries and server response, the error messages, the transfer of resource records between servers. Okay. So we have these sections of the DNS message format, the question section, okay, That is the question for the server. It contains the domain name to be resolved, the class of domain, and the query type. What are you trying to resolve? What are you trying to search? You specify the DNS, the domain name that you're trying to resolve. www, for example, .facebook.com. Okay, or whichever, depend. Maybe within that particular domain, there's a specific file you're trying to query. Okay, or maybe there's a question you're trying to ask. What is maybe a computer? What's a computer, for example? Okay, so you get all the available resources for the same, the answers that are attached to your query. Okay, so the DNS resource record, or RR, for the querying, including the resolved IP address, depending on the RR type. Then authority contains the RRS for the domain authority. Additional relevant to query responses only consists of RRs that hold additional information that will make query resolution more efficient. So you can see the format, the structure of the DNS in case you have any query. So you need to know the following format. That is, these are the most important sections of the DNS message format that you need to understand, especially when doing a query. Okay. Then also we have dynamic DNS. Dynamic DNS allows a user or organization to register an IP address with a domain name as in DNS. That is dynamic DNS. So if you look at actually what we have, the illustration of what we have here, that's what we're trying to explain. The diagram, okay. So the subdomain is mapped to the IP address of the user's server or home router connection to the internet. When a change is detected, the dynamic DNS provider is immediately informed of the change, and the mapping between the user's subdomain and the internet IP address is immediately what? Updated. So the dynamic DNS provider service supplies that IP address to the resolved second level DNS server. This DNS server, either at the organization or ISP, provide the DNS IP address to the resolver. So that's very important. You need to understand that. Then the who is, I know majority you have used this one. Who is a TCP-based protocol that is used to identify the owners of internet domains through the DNS system. The WHOIS application uses a query in the form of, okay, FQDNS. Okay, that is frequently questions, DNS, DN being specified. Then WHOIS is a starting point for identifying potentially dangerous internet connections that may have been reached throughout the network. So the ICANN body or ICANN standard organizations, okay, we'll just check on that. So I can look up an internet-based WHOIS tool is used to obtain some of the, the URL that are registered. Like you can see what we have here. Okay. So that searching is taking place. The other service is NAT service. That is network address translation. When actually you don't have enough public IP address, so in this case you'll be able now to translate private IP address to public IP address and vice versa. Okay, we're translating, but after mapping, remember, in CCNA1 we did a lot of mapping. It could be it could be what, static mapping or dynamic NAT. static NAT and dynamic NAT are the two that we learned in season 1. So we just need to understand the concept of that. So that translation is very, very important. So it means there will be a NAT router that now will be translating these addresses from private to, public. And again, you need to remember that with this one here, the private address, what we said in season 1, the private address in this case is not being routed to the internet. It's not being routed to the internet. But public addresses are routed to the internet. So the solution to the exhaustions of the IPv4 address space and the limitations of NAT is the eventual transition to IPv6. So NAT is being used here temporary. It's not going to be used forever. It's being used temporary just to translate our addresses, the private addresses to public addresses. So what is NAT? As you have said, it's just a service that being used to translate the private address to public address. So we must have a NAT enabled router within our network. So you can see R2 here is a NAT enabled router. That translates the internal addresses that we have, that is private addresses to public addresses. So a NAT router typically operates at the border of a stub network. So a stub network, we say it's a network with only one route. You can see it's R2 to ISP, ISP to R2. There's no any other route. So this is a stub route or a stub network. So it's very important to understand that concept. So in this case, any request coming from your internal network will be directed to R2. Because now it's being directed to the ISP and we are in private, so the NAT service will actually translate. So all our requests coming in with their private addresses, then being converted to public addresses. So how NAT works. How NAT works. So this is a diagram that illustrates how the NAT operates. So in this example, PC1 with a private address 192.168.10.10 wants to communicate with an outside web server with a public address, this. So you can see on this end of the network, you can see we have a public IP address, outside network. Then inside network, you can see we have private address. So this that translation. So if you click the play button, especially on your notes, yes, you'll be able to see that. You'll be able to see that, how that process, is being initiated. So you can see from here, it should be changed to this. So it's good also to understand the concept of that NAT. So inside global, that is inside global, after you can see how it's being seen. You can see, inside the global, you can see how it's being seen. Then outside local, so remember, adjust this one here. Adjust this one here. So it's very important to understand that. So if you look at your student portal notes, then it's supposed to operate the same. Let me see if we can play that. Okay. So you just need to understand that.
Yes, Geoffrey.
Yes, yes. Who is speaking?
Yes, Rashid.
Yes, Rashid.
Yes.
Yes, Rashid.
How comes I'm seeing from the notes there outside global address and inside global address are the same? Yes.
Oh, good. So next, if you have a question,
If we can go back to PowerPoint.
it's okay. I'm coming to that. I'm saying, if you have a question, you can post it on the chat. I'll respond to it. If you have a question, anybody with a question, please let's make use of the chat as well.
Oh, okay.
Okay. I'm responding. I'm responding to it. Don't worry. Okay. So it is chapter. Okay. Am I on the right track? Just a minute. This that video I want to play. Sorry. Since I've opened. Just a minute. Okay. Okay, I think I'm accessing. Okay, it is this one here. Okay, so okay. Okay, so, okay. So network services. Get NAT. So how does NAT operate? How does NAT work? Okay. So this is the video I want us to play. Okay. Okay. So let's click on this video. Okay. So if you look at the video, okay. Look at what's happening. Okay. It's too fast. Okay. Are you able to note something? Okay, let me play it again. You can see the private IP address after translation. Okay, that's what we have. Then, okay, the same one, the same. Okay, so the the request. Now, good. Let's now go back to our PowerPoint, this one here, where it's Rashid or somebody has got a question. Okay, now, so now there are key things that we need to understand here. The key thing that we need to understand, okay? So in this case, if you look at now the request that that we have, okay? So remember, this is what, you know, after the translation of this is what we have. And this what actually will be directed. So remember, this is the NAT enable router. It's the NAT enable router. So this what actually is being sent, okay? And you can see now our request, because now it's a public IP address for us to access the internet. Okay. Now, in this case, now somebody was asking about this one, how comes the same, okay? Which I can, based on what you have seen, actually, I can, okay, this is like maybe it's a typing error or something. Okay, but you see, but it is our what? This is now what we have outside local network or inside global. You see, we have inside global and outside global. So inside global, what will be seen? What will be seen is this one here, inside global. Inside local, what will be seen is here, is this one here. What will be seen is this, okay? But you see, what is being translated is totally different with what you can see here, based on the videos that we have played. Okay, so we can say, okay, this is a typing error. This is a typing error that you are seeing there. Okay, but what actually we are looking at, because the server internal global address given is this one. It's for the server. It's for the server, this one. But what is being translated is this here. Okay, that's our interest. So after, you see, after it has been translated and request being sent, remember what still we have is this. But these terms are just being used to refer to the addresses that we have here. Outside local, outside global, inside global, inside local. So inside global is what we can see after the what? After the translation. Okay, inside the global, what you can see. Yes, it has been translated. It has been translated, but still inside. Okay. Then on the other end, now with the inside global, outside global. Okay. Now what you're going to have, this is now this one, what we have here is what, yes, will be checked, but what should change is this one here. After the translation is this one here. That's what should change after the translation. What are we having? Based on the video, here that we have seen. Okay, look at that. Okay, you can see that's now the source. This now that 192.168.10.10 after it has been translated. So it is inside global. It has not gone through the internet here. So it's still inside. But now it has been translated to public IP address. So it is 192.168.10.10. Huh? Okay, that's what we have. So that's what you can see. Okay, that's now what what has enabled us now to access that particular connectivity, because the private addresses cannot actually be translated or cannot enable you to access the internet. Okay, the same request you can see coming back, okay, as now the destination address being destined to this PC1 which had requested it. Okay, so you can see after that, again, it will be translated now to private for internal, for security matters, etc. Okay, security issues. So it has to be again private because now we don't want the outside network to access your inside network, and that's why it has to go back again to private address. Okay, so that's actually what we have there. Okay, so okay, so I'm failing to understand why outside global address is the same as outside local address. I think that's what I've just explained. Okay, so I thought that could be the same subnet mask but different address. No, based on what we have seen, and based on the translation of Rashid, is it Rashid or who? Yes, Adiru Rashid, based on what we have seen there after the translations. Okay. Of course, yes, we have this one. Yeah, of course, we have this one. This will just remain the same. Inside this one here. Now, you are the ISP. On your end, what you have is local. Is local. But for your case, it's global because it's a public IP address, because it's accessible to the internet. Okay. Then also still you have your what? You have your inside local and outside local. No? Inside local and outside local. Okay. So based on what we have there. So outside global, after translation, of course, there's a typing error. So this one need to change. This one need to change to this because after the translation. But that will not affect this one here. This one must be retained because it's the local. It's the local here. So this one here, 226 here should be the last one outside global here after that translation. Okay, I hope I'm clear, Rashid. Unless you have any question. So now, if you go back to season 1, there are those 4 key terms. First, you need to understand inside addresses and outside addresses. Inside addresses and outside addresses. Okay, those 2 terms are very important. Then, after that, after knowing the inside and outside, so we have now the local. Okay, so we're going to have the inside local address, okay, and inside global address, and inside global address. Then again, we're going to have outside local address and outside global address. So what should change? What should change? Okay. Now, if you look at the port address translations, okay, the part is another term that we have, but within the NAT, because this one now deals with the port numbers. The same process as we can see that you have seen the previous slide, the same process that you have seen the previous slide, but now it has the port numbers. There are port numbers. You can see what is known as socket. So this one has got port numbers. It's the same process, but now with the ports also being added against the various IP addresses, as you can see here. Okay, as you can see. So based on the diagram that we have, based on what we have here, that translation, no? Okay, so the same thing also, if you click the video for that, because it's just here, yes, it is just here. Okay, The process is quite clear. Let's click on the video again. So look at what's happening. Okay, look at what's happening. How the table is being populated. Okay, so it's very clear. That's what you need to understand first. Okay, look at what we have. Okay, because you see, we have, as you can see, PC1 and PC2. Okay, which request is being directed where? So source address and destination address. You can see we have different destination IP addresses that we have here. Okay. Then after translation, you can see that translation. You can see the ports are being assigned. The ports are being assigned. Okay. To various destinations or to various servers that we have. The port address translation. So in this case, they include the port numbers as well. We have file transfer and sharing services, FTP and TFTP. So FTP, all file transfer protocol, allows data transfer between a client and a server. Okay, and a server. And as you can see, normally with the FTP, okay, so you normally have control connection and data connections. That is, you remember port 20 and port 21. Okay, so control connection, the client opens the first connection to the server for control traffic. Data connection, the client opens the second connection to the server for data traffic. Okay, what we have there. So also we have a trivial file transfer, a simplified file transfer protocol that uses well-known UDP port 69. Okay, port 69 for the UDP, the well-known port number for UDP. Then also we have SMB, server message block. Server message block is another protocol meant for sharing, okay, the resources that we have, especially on the servers. And this one, the good thing with this particular protocol is that you can do a sharing on the server so that the client will be able to see everything on their end as if they are installed there. For example, you can share this printer. The printer will appear on the client PC as if it is installed here. Okay. So it's make it to appear in the client device as if it is installed there. So making it more shareable. Then also we have the email services. And when it comes to email, in this case, we have various email protocols for sending, okay, the emails like simple mail transfer protocol, post office protocol, and IMAP, and others for retrieval, sending and retrieval of emails, which must be enabled again on our servers. Sometimes you might be wondering, how comes I'm not receiving any email? Okay, so these are the protocols that you need to check, to enable on your server to ensure that now you are able to receive email from your colleague. Then for the IMAP and POP, as you have said, these are retrievals, protocols, as we have said. Okay, you'll get it into your inbox from the server. It's being delivered into your inbox. So for example, you can see when transferring the emails, also SMTP in this case will enable you to send the emails from your device to the client's device. I mean to the receiver's device in this case. So it's being, you can see what's happening. SMTP up to the server here. This server transfer it to this one, okay, because it's in a remote network, okay. Then it will be delivered into your inbox. So you can see when the server receives the message, it either places the message in local account, okay, if the recipient is local, or forwards the message to other mail server for delivery. So it depends with where actually you are located. I might send you an email, but you are just within the local network. Or I might send you an email, but you are on a remote network. So all those will be considered, and various protocols that we have will take their responsibility based on that. Okay. So for POP, you can see used by an application to retrieve mail from a mail server. So with POP, emails messages are downloaded to the client and removed from the server. The server starts the POP service by passively listening on TCP port 110 for client connection. So again, it's very important to understand various protocols and their port numbers. It's very important to understand that. So SMTP is port number what? POP is port number what? IMAP, okay, is port number what? Because also we have IMAP, which is also a retrieval protocol in this case. Okay, so now again, what you need to understand between this protocol IMAP and POP, okay, is how actually the data is being stored. For example, okay, now with IMAP, okay, you can see that with IMAP, the original messages are kept on the server until manually what? Deleted. Okay, but with the POP, okay, now you'll find that those, okay, you can see with the POP, email messages are downloaded to the client and removed from the server automatically. After it has been delivered, a copy has been delivered to your inbox. So whatever traces remaining in the server will be removed automatically as long as it has delivered it into your email. So it creates space for the other incoming emails. Unlike the IMAP where you'll have to do it manually, you remove one by one manually. So that's the main difference between the two, POP and IMAP. Then yes, we talked about HTTP service and how we normally do request. Okay, so most important thing here is to understand various parts of the HTTP. What we have here. Okay, the browser interprets the three parts of the URL. We have the protocol itself here, or the scheme. The protocol, okay. We have the server name here, and what is being requested from the server. Index.html is what being requested. These three parts are very, very important. Okay. We're actually now using the HTTP. So you have to give the right path and the location of where the file is. Still with the HTTP URL, as you can see, now what we have here, it can as well specify the port on the server that should handle the HTTP methods. The ports sometimes can go down further and indicate the ports where various resources can be accessed. So it can specify a query string and fragment as well. Query strings are preceded by a question mark, as you can see, a question mark here, and consist of a series of name and value pairs. So various parts of the URL that you need to understand, the protocol, the domain, the port, the path, and what is being queried. It's very, very important. Then you also have the fragment. It's preceded by hash character. It refers to a subordinate part of the resource that is requested in the URL. So the parts of that URL are shown here. Okay. So various parts of the HTTP or the URL that you need to understand. Okay. Then normally there are some operations of the HTTP. The operation of the HTTP, okay, like the get, post, put, delete options, and connect are various operations. So depending with what you are doing, depending with the operations that you are doing. So HTTP is a request response protocol that uses TCP port 80. It is flexible but not a secure protocol. Of course, it's not secure. That's what we said. So the only one which is secure is HTTPS. HTTPS is the most secured one. Okay. So get, post, depending with who is requesting, who is responding. So this is how these particular messages will be applied, or these methods will be used here. Okay. Okay. Then again, it's very important to understand various codes of the HTTP that we have, the response codes that you guys might sometimes come across. It's very important to understand those codes, and normally there are 5 codes. You can see normally they are numeric, with the first number in the code indicating the type of what? Message, okay? The kind of message. So that one is very important. That 2, they're just giving you the messages that you need to understand. Like anything to do with the 1 is just what? Informational message that you are getting. Okay, anything to do with the 200, is something which is successful. It's a success message. 3, redirection message. 4 is client error message. 5 is server error message. So when you get such kind of codes, you should be able to interpret them correctly. Okay, because now the machine is communicating with you, and you should be able to interpret those ones as they are. Okay, so based on what we have here, you can see 100. Okay, so the client should continue with the request. The server has verified that the request can be fulfilled. So it's just an informational message you are getting. 200, success. Okay, the request completed successfully. You can see even 202 still under success. It has been accepted. Your request maybe has been accepted. Okay, so we have also 400 client error message. Okay, so it could be 403 forbidden. The request is understood by the server, but the resource will not be fulfilled. This is possibly because the requester is not authorized to view the resource, so forbidden. 404 not found, the page not found. The server could not find the requested resource. Okay, from the client. This can be caused by an out-of-date or incorrect URL that has been entered. Okay. Now we have also HTTP/2. Okay, it's just to improve the HTTP performance by addressing those delays that might be experienced on our network, the latency issues or the delay issues that might be within the previous versions of HTTP 1.1 of the protocol. So it uses the same header format as HTTP 1.1 and uses the same word status code. Okay, only that it's there to improve some delays that were being experienced with the first version, with the older version. So a few important features of HTTP/2 that a cybersecurity analyst must be aware of are multiplexing, especially when we have given the part of the bandwidth to share. You send, I send, you send, I send, multiplexing. Remember what you said about multiplexing our network. Okay, server push, binary protocol, header compressions. So it's just an an improved version of the what? Of the older version that you need to know. Okay. Then also we have now HTTPS, which is a secure protocol. Okay. Then HTTP. And you can see this one uses the authentication and encryption to secure data as it travels between the client and the server. So it uses the same client request server response process as HTTP. But the data stream is encrypted with this one, secure socket layer or transport layer security before being transported across the network. Okay, so this one you can see also we have the proper version of the same specified to use HTTPS over TLS with the application layer protocol negotiation extension for that. So confidential information is transmitted over the internet using HTTPS. Okay, so those are the various network services that we have. Those are the various network services that we have, and we need to understand how they are operating. Okay, so let me ask, did you guys manage to go through the labs or the lab had given you? Guys, did you manage the labs, Rashid? Okay, of lab 537. How about the other one? It was 537. Okay, let me confirm. Oh, okay. Now you guys, if you can also present what you have done, then I will be the happiest person, because that means you are getting what you are being trained. Yes, it is lab. Yes, same lab. Now, Rashid, do you mind? Is it Rashid? Let me see. Is this Lamina? Okay, Lamina. If you don't mind, can you take us through what you have done? Lamina, are you in a position to take us through what you have done? Okay, you can unlock yourself or unmute yourself.
Good morning.
Yeah.
Unfortunately, we are having power issues here at my location, so I'm using my phone currently. I used my computer for the rest of the night doing this lab practice. I should have been very happy to present to you guys, but as you can see, I'm using my phone. I used to connect with two devices, but today I only have the chance to connect with my phone for me not to miss the session.
Okay, okay, there's no problem. Thank you. Thank you for that effort. Thank you. Okay, let me see. Who else managed to go through the lab and want to take us through what he or she has done? Let me unmute Florence. Florence, are you there? Unmute yourself. Okay. Yes,
Hi, Geoffrey.
Florence.
I am
Hi.
here, but
Yes.
I think I missed maybe the last 5 minutes. I was attending to something, so I'm not quite sure where you are or what I'm supposed to respond to.
Oh, sorry. This lab I gave you last time, huh? Lab 537.
Mhm.
Did you manage to go through the lab?
Not yet, sir.
Okay, okay.
Mhm.
About Rashid, unmute yourself. Rashid.
Something going on? I don't know, Salifa.
Rashid. Rashid, you can unmute yourself. It's a pop-up on your screen. If you can see it. Okay, it seems Rashid is not there. About okay. About Adeboye. Adeboye, unmute yourself. Adeboye. Oh, these guys are not available. Adeboye. Okay. Let me check. Mutiat, are you there? Mutiat? Hi, Mutiat. How are you?
I'm fine, thank you. And you?
I'm good.
Yes, I've not done it. I've not done it.
Oh, you're not clear, Mutiat?
Can you hear me now?
Yes, now it's okay.
Yes, I've downloaded the game, but I've not been able to.
Are you walking? Mutiat, are you walking? Or
Yes,
are you?
yes, I'm working. I'm working.
Yeah, because there's a lot of background noise from your end.
I hear you. Can you hear me clearly now?
Yes, yes.
Yes, I said I've downloaded the game, but
Yes.
I've not been able to.
That part of you're not able to do is where you're getting lost, huh?
Yes, so I'm trying to open where the PC I downloaded is, because I'm using two devices now.
Okay. Okay, thank you. Who else? Yes, my friend Winnie. Winnie.
Hello, Mr. Geoffrey.
Hi, Winnie, how are you?
I'm very fine.
Yes. Long time.
It's been a long time, yeah. I'm really sorry I didn't attend the Monday class and I didn't watch the recording, but I'll work on it tonight, then I'll present it tomorrow if it's okay.
Okay.
Yeah.
So do you want guys, I give you time to work that lab and present it tomorrow?
Yeah.
Okay. Because also I can see my friend Lamin also is willing to present. Yes, if you're willing to present, I have no problem. So it's no, so guys, you can just work. Then that means because it was only one lab. Let me see. It was only one lab there. Maybe if we can have then, if you're much willing to present, can you have those two? Then can we have two labs? We can have lab? Okay, let me check. Because guys are willing to present. If you can have lab, okay, the same lab 537, and also you have lab 8. Let me type it on the chat. 828. Okay, lab 828. Okay, that's lab 8. Lab 8. Okay. Because yeah, I think those two labs, if you guys can present these two labs, lab 5 and lab 8, lab 537 and lab 828, then that would be okay. Is that okay with everyone? For those who are using their laptops, and those who are using their phones, it might be a bit tricky. It might be a bit tricky because we'll not be able to work on that as well. So I think that will be okay. So tomorrow, I think tomorrow the first thing we're going to do is to present those two labs. I'll see what you guys have done. So let's start by presenting those two labs tomorrow in the morning, our usual time, 11 to 1 East African time. Then after that, I can see what I can give you guys again. Okay, I think that's all from my end. We have 25 minutes remaining, but let me see, I cannot introduce the new chapter. I'll not be able to introduce the new chapter. Let me just stop here so that I can give you guys time to go and work out those labs. Work those two labs, that is lab 537 for those who haven't done it, and lab 828. Those two labs. As tomorrow we can meet and present what you have done. I think that's all from my end. If there is no any other question, then why